Hi everyone and welcome to the next video in the series of tutorials for the Siemens NX practical course. Today we're gonna skip some parts again. Last thing we have looked at was that one. I heavily suggest you to do this and this. Especially that one is something that people run to trouble often. Just it's no big deal to model it. I guess you can do it almost exclusively using extrude, and I think also some revolving. But the problem often is not understanding the sketch, and I see, and I think I myself had problems when I was in the course, when I was doing it myself as a student, to do it. And I'm not sure, it's always hard to explain if you already didn't understand, but let me try to give a quick explanation now. Yeah, so first of all, what is it? It's this driver's cabin of a excavator. It's hollow in here, of course. It has a window here, a window here. The front should be hollow because, of course, otherwise we wouldn't see in, but the back isn't, okay? That's something that you can see from this section. It goes right through, so it cuts right in half. And here you can see the back wall is solid, while we can look through, so these two windows aren't solid. And also the front, and that's a little bit harder to see. There's also a window, of course, otherwise you couldn't look out. That's a place where you can also use like real life logic, but you can see here we are missing these lines that we have here. So here we just see the back wall thingy, this little pillar, okay? And also, because we have the cut right here, we can see that basically this shape right here, not regarding the round thing, this shape should be kind of a section which makes out all of the inner part of the excavator. And then we additionally need this wall right here on the two outsides, so that's also closed. But the inner part of the excavator looks like this. So you can use this sketch and extrude it along here and then add the outer walls. That's one idea that I have for you. It's a bit tricky to measure all of this, and it's important to realize, or to sketch all of this, it's important to realize that there are, that's one tip, these dotted lines in here, which are the actual board. Then there's this outer line right here, and that's because we're cutting exactly through the middle. Only this knob, which looks out, and also tells you that that's a cylinder, which goes into the board right here, but here we see the outer rim of the cylinder, okay? And that's the outer rim of this board. I hope you can understand that just by explaining it to you. You can see the cylinder from the top somehow here. And here you can also see it from the side, how the cylinder sticks out. And you have, that's why there's a diameter. And this board is just that part, okay? And that part, to come back down here, you can see only by these dotted lines. And to model them, it helps realizing that these should all be parallel, okay? Where the arrow is pointing. So, and one more thing, missing measurements can be chosen freely. That refers to the top right here, because it's not given how these arrow vents or whatever that is should look, and these you can just model yourself. by cutting them out in the end, probably. Or maybe you could even introduce it already in that sketch if you want. Okay, so I hope that could help you. If not, you can still ask in person. Then it should be easier to help you out with that part. It's again a nice exercise to just get along with technical drawings, reading them and really understanding them, because I think that's the tip of the iceberg already, almost. Okay, maybe that was the wrong idiom, but that's the hardest that's the hardest technical drawing to read, in my opinion, and also in my experience for students. Also, that's a nice part to do that I recommend for you. The screw we will probably look at in another video, because it's another very special function that I have never seen in an exam. But to make sure, I will show you how to do it in case it should come up, but I really don't hope that it will come up in an exam. But you can see it definitely. I can show it to you, I guess. So in case it comes up, then you will also manage it, because it's also not that much to do. And then we are getting into territory of parts that you don't really need for the exam, I would say, or where I would be confident that if you have all the other parts, then you're fine. That one would be one of it. Especially these, if I remember correctly, are a bit freehandy, so not too much measurements given here. But don't nail me on that. I'm not too sure, because, to be honest, I have never modeled that myself. Same goes for that one. That's something that you could do, definitely, if you need some more practice. That's nothing too crazy, definitely, but that's why I won't show it, but you can do it. And I want to show this part today, which is very short, but it shows one more function that is very similar to sweep along guide, as you might already see, because we have this tube right here, again, constant wall thickness of 1, that says that it's a tube. But the difference, what we can't do with sweep along guide, is that we have 3 different, I always forget that word, 3 different cut surfaces right here. It's a circle, another circle, and on top this shape, whatever it is. And that's something that we need a different function for, but it works kind of the same as sweep along guide. And if you already wrapped your mind around how a sweep along guide works, it won't be big of a deal for you. So we need definitely a guideline and 2 cutting planes right here. And I would say we start very simple with the first cutting plane down here, with the first section, that's the right word. I'm drawing on top, and I'm simply doing a circle with a diameter of 18. A little tip, I might have mentioned it already, always make sure that you're not confusing diameters with radii. That's always the sign for a diameter, and an R, like here, is a radius. But I guess you will also realize if you make that mistake at some point. So just a little heads up, something to always keep in mind. So we have our first cut, and what I already started is the next step, which I think is intelligent to do now, and that's the guideline, okay? And the guideline is also no big deal for you, I would hope, because it's something that we have done a lot of times, at least similar. So I'm selecting the profile tool again, doing a length of 47. Then I'm doing some rough estimation of how it should look. Here I'm not defining any length again. I'm doing another rough estimation, and I guess we also need a little line in the end right here. Okay, so that's the shape that we need, roughly. Now let's give the dimensions that we need. And that's not the one that I wanted. I wanted the outer point to here. And that distance should be 90, as you can read from the technical drawing. And we are pretty close to that already, so that's nice. Okay, let's add the radii. That one should be 15, and that one should be 15 too. Now the height, which should be 150, not 115. That's not right. Okay, now it messed up something here. That's not so nice. Okay, I managed to drag it back. Never mind. And now we still need this angle probably. Let's put that in. Drag it here, 55. And our sketch is fully defined. That's nice. So without much thinking again, just putting in the measurements that are given, we have our guideline. And now let's next do the next easy thing, which is this sketch, which should be in the end. Okay, and that's something new, because now we need to sketch not on a plane that is already given. And one thing we could do, definitely, if that's an idea that you have, go ahead. You could select the datum plane, go to the type at distance right here, and then select the ZX axis and do a distance of 90, I guess it was, so that we have a plane exactly at the end here, okay? Because that distance was 90, if you remember from our guideline before. Then you could sketch on this plane. That's a cool idea, I guess, but I want to show you something else which is even cooler. At datum plane, the function we have used, which I showed you right now, was at distance, but something else that's pretty cool is on curve, I guess. I hope that's the right one. And now we can select that as a curve, and now here I can show you. I can drag it around. We can put this on a curve, the plane, sorry, and it will always take the curve, or the point which it is at right now at the curve, as its normal vector, and yeah, like that you can define a datum plane 2, and we want it at arc length 0, so that it's at the end. Here you see direction normal to path. That's okay. We click on OK, and now we have sketch, which a plane which is exactly where we want it, and we can now create a sketch on this plane. And now we could also make our life a bit easier, I guess, and use that, specify origin point, and click on the endpoint right here, so that our coordinate origin is exactly on that point. So looks a little bit weird right now, but you can see we are now on this surface out here on the end of the point, and here we can simply draw our little rectangle shapey thing, which I'm doing pretty freely. It should be 8 and 20, and then let's give the measurements right here. That should be 10, and again, because I like it so much, to make coincident with our middle point and this line. Oh yeah, there it is. Okay, sketch is fully defined. It looks good. And I forgot, we need round edges. It says radius 3, so let's use the fillet function with a radius of 3, which makes it very easy in that case again for us. 3 again, and one more time. Finish. And now we have 3 of the 4 things that we need. We have two of our sections and our guideline. And the last thing, which is a bit harder, is the last section. Because, well, we know now a function that we could use, which is that point on... because the problem right now is we need a plane, right? And we could use the same thing as before, you could think, and do a plane. Okay, something's messed up. But do it as I showed you before, a plane on this curve, and then have it at the right direction. But problem is we don't know at the right distance. But the problem is we don't know the distance. We only know that it should be 107 from our y-axis in that case, or x-axis from our xy plane down here. So the easiest thing to do that, I would say, is introduce a point again, as in the video before, and we don't need an extra sketch for that. I would say we can just introduce that point in the sketch of our guideline. So use the point function. I'm laying it somewhere on the line, and now I'm selecting the point, hopefully, at least. That's a bit hard to do, but I got it. And select a line down here, and we need 107. I almost eyeballed it with the 106 that I had, but now you can see we have this point on our line with a distance of 107 to the ground. That's exactly what we need. It also doesn't mess up the sweep along guide function. Later points don't do anything if they are on a line in a sketch, so it's just for orientation to now lay a plane on there. And we are not using on curve this time, but we are using point and direction. And at that point, maybe I want to give you a little motivation to use something like this, these drop-down menus. Often, well, you don't need them, but I mean, for the datum plane now, you, for example, need them, or also when you want to specify vectors and something. Often, these look very overwhelming, but just by reading what it says and seeing the little image, you often understand immediately what to do. Like, for example, if you're now in the exam and you forgot which function to use for that, just think about what you got and how you could do a plane based on that. That needs a little basic geometry, but I think you still should have that from school or uni. And it's very basic. So what do we have? We have a point, and we also have a vector right here, and that's again just a point and a normal vector, and that's enough to do a plane exactly in the way that we want it. And well, point and direction, that's what we have, so we could use that. And the rest you see is also pretty easy. At distance and looking at the image tells you that's a plane, at distance to another plane. At angle is a plane, at an angle to another plane, and so on. Two lines, of course, also pretty... I've never used it, but I would imagine that you can there select 2 vectors, and then it creates the plane that these 2 vectors define. Like if you would use the y and z, then it would use the yz plane. So we need point and direction though. Use the point, use this direction, which is just that part of our guideline, and click on OK. And you can see now we have our sketch here. And rinse and repeat as before. We create a sketch on that plane. We specify origin point. And while we're already at it, you see here's a lot of functions. And inferred, mostly signaled by this little yellow lightning bolt symbol, always means that you take something from the mod or from the features that you already have. So we infer a point which is already there, kind of. And then the other options, if you hover over it, for example, cursor location, that's kind of nonsense in the 3D space often. If you have not locked your vision to one plane, existing point, that would probably also work. That's kind of the same as inferred in that case, at least. Here you can select the end point of a line, control point, center of something. So you see, all of this is pretty intuitive if you just read. Look at the picture and read. But we simply need inferred. We can leave it at that. Select that point. Now you see our sketch is on this plane with that as the origin point. We click on OK, are now in our sketch. And all we need to do here is read. It says the diameter of the part at that point is 16. So we draw a circle in our origin of the sketch that we just created with a diameter of 16. That should also leave our sketch fully defined already, because we selected, specified the middle point and diameter. And now we have everything we need to use the last function that you learned in this course. And that's not sweep along guide this time, but very similar, swept. And that's a function that you can also find not over the search, but as you can see, it now popped up under surface. Make sure you don't use swept volume, but swept only. So you can also find it up here, but I always like to use a search, and I want to encourage you to do the same. And now I already selected this section curve, which I don't want, so I'm closing it again and opening it again without anything selected. Remember to deselect, simply click escape, and you will have nothing selected anymore. So now, let's look at this function. Remember, sweep along guide needs a section and a guide. And here it's kind of the same. You can use multiple sections and also multiple guides, but we will always only be working with one. And to select our sections first, we simply click on the first. And now it's important that you, similar as in the last video with the edge blend, add a new section. If you want to see your sections, you can also again expand down here and have a look at a section list. That's our first section. That's our second section. Don't forget to add a new section. That always leads to errors, and I also always forget it, so that might be a problem often. Make sure they're in the right order. Section 1, 2, 3. Perfect. And now we also just need to add the guideline, which is that one right here. And now it looks all messed up, and that's actually, or sadly, something that happens a lot with this function, but it's luckily nothing that we can fix. But it's a little bit more to understand, but once you understand the function, again, you can work with it. So this function works by, now we are talking about how it works in the background, the program, at least an abstraction of how it will actually work, by selecting a starting point on the first section and also on the second and last section. You can see the starting point is where this little arrow right here starts. Might also be that. Sorry, no, I think it's where the arrow starts. And then there's a direction. And then it says basically every probably infinitely small point in that direction on the edge from the starting point. So point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you know, around here, will be mapped onto the next section starting from its start point. And then in that case, we have that direction, 1, 2, 3, 4, 5, 6, 7, and so on. And then these points will be mapped to the same points starting from here, okay? And now you might already have realized the problem right here. If we are mapping the points 1, 2, 3, 4, 5, 6, 7, 8, 9 onto these 1, 2, 3, 4, 5, 6, 7, 8, 9, then we are always mapping. The first point should still be correctly, of course. That one goes here. That's okay. But then the second point will go kind of through to the other side. And especially if we have a look or think about the point which is exactly 25% of the whole length of our sketch. So in that case, a quarter of our ring down here, of our circle, then that point will be mapped exactly to the other side, okay? I hope that was explained well. And the easy fix for that is switching this direction, for example, because then it's nice that NX already has chosen kind of the same parts here as start, the same points. So we don't have to change anything there. The start point is fine, but we need to change the direction, and we can do that by double click. It already says it. Double click to reverse, and now you can see it looks way better. It's actually perfect already, because now we have the points all on the same side, and we have the same directions. So far, so good. If that worked for you in the same way that it worked for me, let me click on OK. You can see that's our part. Then everything's fine and perfect. But if it didn't, and that's also sometimes the case, it's a little squishy. Sometimes it works, sometimes not. In that case, usually the problem, after you made sure that the direction is the same for all of the all of the arrows are pointing in the same direction, then the problem might be that the starting points aren't the same. Because imagine if we had the starting point of this circle here on the other side, then it would start mapping the points wrongly. Then it would start mapping this point there, and then all the points 2, 3, 4, 5, 6, 7, 8 that go in that direction to here, 2, 3, 4. So it's again mapping every point exactly to the wrong side. That's also something that can happen, and that's a bit harder to fix. But I want to show it to you probably. But maybe, okay, I recommend everyone looking at this, even if it worked for you. So one of the fixes for that, what you can do before you even start, is that problem often happens with, or actually, you know what? Give me a second. I'm gonna start a new part, and which is a bit better suited for explaining that. Okay, here we are back again, and I've drawn a much easier version of a part where you can use the swap function, which is simply projecting that onto that with this as the guideline, which is just a straight line in that case. So and now let me first add the guide, because that's straightforward, and go back to the sections. And now I want to make you pay attention to where I click, okay? So if I add my new first section and I'm clicking close to this edge in that direction. that wasn't well. Let me first let me do it again, and select the guideline afterwards, because then it's better to show. That was a bit dumb. Okay, first select the same. I'm selecting the guide later. I'm clicking here, and now you can see, because I clicked close to that edge on that side, it made the first point start on this edge, or on this point, and the direction where I clicked. If I'm clicking, if I delete it again and I click here, then you see it's the same but for that point. If I'm clicking here, it's like that, okay? And if I'm clicking here, it's like that. Yeah? So I'm doing it like that. And now, if you understood what I mean, add new section. Did I do it? Now, I would obviously have to click here because we want that that's the start point which is mapped onto here, and then all the points along this line should be mapped to all the points along this line, and so on. If I don't do that and click here, for example, and select the guideline, it will look like this. And that's also something that you might get. Because now you can see our directions are fine. If I reverse the direction, it's even worse. It's basically an impossible shape because you see the output is self-intersecting. The planes are going through each other and it gets infinitely small here. And like that, it's a possible shape, but it's definitely not what we want because we want it to be mapped on here. So if something like this happens and your direction is correct, then the problem might be not the direction, but a starting point. And to change that, you can, well, in that case, I would just cancel, start the function again, click, pay attention to where you click, add a new set, click here, so that's the same point, click here, and you see all done. Problem fixed. The other thing that I want to show you, I will show you after cutting again and preparing a new thing. Okay, I'm back, and now you can see I've slightly changed our example. Now we want to map this onto a circle, which is a little bit more as it was before. I'm clicking here again, and now, well, where do I click for the circle? That's the problem. We don't have corners here. And you see, okay, the problem now was I didn't add a new set. Let me do it again. I did both as the same guideline. So let me click on here, add new section, and now let me click here. And you can see I clicked here, but it NX didn't take that because it just starts, I guess, on the x-axis. And now, if we select the curve, you can see that's probably not what we want. It's still twisted in some way. And to fix something like that, we can do it before we even think about the function in the sketch. Because our problem was NX doesn't know where to start, and we don't have points on the circle because there are infinitely many, and we don't have these characteristic points, which are edges that we can select. So why not simply, and I don't have to do that 100% accurately, I guess, at least I won't do it. If you need the accuracy, you can do it. But I'm now kind of drawing here two diagonal lines in this rectangle, and now we can trim. Where is it? That, and that, and maybe convert the other ones to reference, for example. And now I hope we should have points here to make sure we can also take the points and put them at the intersections. So 1, 2, 3, and 4. Okay, now our circle has points. And now I hope, if I go to the swept function, oh, come on. What is it doing? Okay, now I can select this section right here, add a new one, now click, well, that didn't work as intended. Okay, so that didn't work. Sorry for that. It's one idea, and there is also a way to do it like that. But I realized the more intelligent thing right here would be to split the circle into, and I'm gonna do that right now. So we can convert our circle to a reference line, and now we take arcs, select these points, make them tangent to the circle, which is a little bit hard, and we are actually reconstructing our circle, but in 4 points. Oh man, and that was not what we wanted. Come on. Like that. And one more. Like, no. Yeah, you will probably run into the same problems. That requires, yeah, like that. To be patient, but we are patient, so no problem. And now I hope it should work actually, with that additional step. Select that one, click here. Select that one, click here, and now you see it worked. It realized that break in the circle, and used it just as it would use a corner. And now if we click on OK, you see that looks much more like it, I would say, because now all the lines are projected exactly to the circle. Of course, you could do these breaks in different points if you want these lines to go differently, but the thing to take away with here definitely is that first of all, what you saw in the part before, in our model 4 right here, it's important in which direction the point goes. If the start point is the same, it's important that the start point is the same, or is the one that should be mapped onto each other, are the ones that should be mapped to each other. And then if you have a circle and you want to make sure that that works, and it doesn't work by default, you can chop the circle into n different parts, however many you need. We needed 4, and then MX will realize how it works. So that was actually a very long video for such a small part. I mean, in the beginning I also went into into the other part for a short time, but I guess that's already everything you need for this swept function. And the good message here is that that was the last function already. So to recap what we have learned and what you need for the exam, therefore, is first of all, most importantly, extrude. Second of all, revolve, and then swept and sweep along guide. That we have, that you can only find via the search right here, sweep along guide. These are the creating functions, and then of course you need to know shell, draft, chamfer, edge blend, which we all have worked on. We have also had a short look on whole, which I don't deem as important, but maybe you might need it, so better make sure that you are familiar with its functionality. And then also, I think pretty important, of course, making new planes, and these two functions. The mirror feature, which we have used multiple times, and the pattern feature is something that's maybe the best tip I can give, at least at the current state in 2022. That's a very common function in exams. And that's why the next 2 videos will focus on this function, because we have used it so far, as far as I know. I think not in a video though, and yeah, I want to use the rest of our time, 2 more videos, to explain this function in depth and show 2 parts which use it. So I hope you could learn a lot again. I mean, it's just one function, but now you are professional users of this function, I guess, because you should be able to catch every error that comes up. And if you're lucky, you only need the first 20 minutes of this video, or 25, or however long it was, and you don't need to catch any errors at all, because NX will be intelligent enough. So thank you for your attention, and we will see each other next time.